Okay. So when it comes down to determining all this information for rational functions, which we've been doing last week. Okay, we started doing it with the properties of rational functions. That was the first part of unit 4. That is what you were doing for the first bit. We had to find the asymptotes, find the holes, and then find the x-intercepts, also stating the domain. Friday is what you guys did with the graphing part. Okay, so really and truly, that first part, everybody should be able to do pretty well. Okay? Determine any asymptotes. Okay? Well, there's 3 different types of asymptotes that you can have. Somebody give me one in the classroom. Vertical. Somebody online, give me another one.
Slant.
Horizontal.
Hold up. Sorry, I gotta fix my sound because of the thing. Okay, say it again.
Horizontal.
You got horizontal asymptotes, and then of course the last one is oblique or slant. Okay, so you have to determine, you have to find those. It's either, you always don't have vertical, sorry. Always need to look for a vertical first, and then see if you can either gonna have a horizontal or a slant. You're not gonna have both, it's gonna be one or the other, okay, for horizontal or slant. How do you find a vertical asymptote? Somebody in the classroom, how do I find a vertical asymptote? Said the what? I said the denominator equal to 0. That's how I find a vertical asymptote. But there's one thing I gotta be careful of when I do that. What do I be careful of? Holes. So really and truly, because can you have a hole and a vertical asymptote at the same point? No, you cannot. You cannot have a hole and a vertical asymptote at the same point. It's either gonna be a hole or it's gonna be a vertical asymptote, but not both, okay? So actually, let's find the holes first. Let's do this one first. Were there any holes?
Yes.
Where? When the x-coordinate was -1. You find the hole by taking the canceled out factor and setting it equal to 0. So when you take x plus 1, that canceled out factor, set it equal to 0 and solve, you get -1. But it's not -1, 0. I saw a lot of you guys on your homeworks on Monday, y'all kept saying the hole's at -1, 0 or -3, 0 or some other number 0. But that's not the case. How do you find the y-coordinate of a hole? You plug that value into the simplified version. We have x minus 3 over x left over once we cancel out that factor. So we have to plug 1, -1, into that simplified form. That is how you find the y-coordinate of your hole. So then that becomes -4 over -1, which equals 4. So our hole actually exists at -1, +4. And make sure that we draw holes with open circles. Okay, very visible, please, on your paper. So now that I've taken care of my hole, I actually don't have 2 vertical asymptotes, I only have 1. Where is it located?
0.
Be a little more specific. It's x equals 0 for your vertical asymptote. You find your vertical asymptotes by setting your denominator equal to 0, the simplified denominator equal to 0. How do I draw a vertical asymptote? With a dotted line, okay? So x equals 0. Do I have a horizontal asymptote? Yes. Where?
Y equals 1.
It's y equals 1. Remember, for your horizontal asymptotes, you have to look at the what?
The power.
Of the top.
The degree.
The power of the degree of the top and the bottom. Since they're both 1 and they're both equal, the horizontal asymptote is always what? Is the coefficient of that variable and the coefficient of that variable. It's not always y equals 1. In this particular case, it is y equals 1. Intercepts. You have x-intercepts and y-intercepts. How do you find your x-intercept? I said the numerator equal to 0. Yep, so the numerator equal to 0, so x is going to equal. And intercepts are points, y'all. So this is going to be 3, comma. That's where the 0 comes from the intercept. Oops, I forgot to draw my other stuff. Hold on, sorry. Horizontal asymptote of y equals 1. X-intercept at 3, 0. How do I find my y-intercepts?
Plug in 0 probably.
Plug in 0 for all my x's. Ooh, but when I do that, what do I get? It's undefined. I get -3 over 0. I can't have that. So that means there is no y-intercept. If anything over 0, any number over 0 means there's no y-intercept. If you get 0 over 0, that means you can simplify and then try again. Okay? Lastly, we have the domain of this rational function. Okay? Domain is all real numbers except where the function is undefined. What makes a function undefined?
0 in the denominator.
0 in the denominator, okay? Well, is that the denominator of the simplified form of the original thing?
Original?
The original, because remember, wholes are points of discontinuity, just like vertical asymptotes or infinite discontinuities. So you always want to take it from the original. So my domain is going to be all real numbers except what?
0 and -1.
0 and -1. Because remember, there was a hole at -1, so that's 1 point of discontinuity, and at a vertical asymptote is 0. So it's all real numbers except where x cannot equal 0 and x cannot equal -1. So in interval notation, that'll be -infinity to -1 with the parenthesis, connected with the union, -1 to 0, connected with the union, 0 to infinity. Because everything except where it's -1 and 0. Questions on the property part before we actually get to the graph? So to graph this, if you watched the video on Friday, you would see that if you do have branches, you should always have 2 of them, okay? And they should be in like opposite areas. Definitely needs to go through the x-intercept, so I definitely don't have a curve in my bottom right, but I also need to make sure I go through my hole, which is in my top left. So that's where our 2 branches are going to be. They should approach vertical asymptotes and horizontal asymptotes and curve towards them, okay? Again, approach horizontal asymptotes, approach vertical asymptotes. Don't cross them, don't touch them, unless in the situation where it's a horizontal asymptote and an x-intercept at that same point. That's the only time you actually cross over a horizontal asymptote. Horizontal asymptotes tell you about your end behavior of a rational function. Y'all remember hearing me talk about that in the video?
Yes, ma'am.
Okay, so for this particular problem, what would be my end behavior? Wasn't a trick question. Literally just said the end behavior, the horizontal asymptote tells you what your end behavior is. So the limit as x approaches infinity, as x is getting bigger and bigger and bigger, your y's are getting closer and closer to 1, your horizontal asymptote. Same thing, if I'm approaching negative infinity, I'm getting closer to 1 still. That's how you graph a rational function. That's how you find all your features, all your properties. Questions?
What if we simplified when we're trying to find a whole and we ended up getting the simplified version is just a linear equation?
And it's a linear equation? That can happen. That can definitely happen. What that means is that it doesn't mean that it becomes a linear function now. It means that it's a rational function still that got simplified down to be a linear function. Like, I believe there was one like that on your homework, right?
Yes, ma'am.
What
And I
was
was so stuck on that.
All right, what was it? It's a great time to go over that.
It was x squared minus 4 over x minus 2.
Okay, I think you had to find all the normal stuff like before. Okay, so was domain one of the things you had to find? No? Okay, so we didn't have to find domain on number 1 from the homework. Okay, but we did have to find holes, didn't we?
Yes.
Yes.
Does the top of the function simplify?
Yes.
Okay. Or sorry, not simplify. Does it factor? Does it factor? To what?
X minus 2 x plus 2.
So as we can see, we have a common factor that can cancel out, and we're left with x plus 2. Remember, you take the canceled out factor and you set it equal to find the x coordinate of your whole, which is going to be located at, you find the y coordinate of your whole by plugging the 2 into x of the simplified equation. So then that becomes, so I have a whole located at 2, 4. All right. That's good. Vertical asymptotes. There are none. Because remember, you have to take the denominator, set it equal to 0. Well, in the simplified form, I don't have a denominator anymore. So that means I'm not going to have a vertical asymptote. Do I have a horizontal asymptote? No. I need a denominator to have a horizontal asymptote. Same thing with slant. I need a denominator to have a slant asymptote. What do I have?
Do you have a slant asymptote?
No slant asymptote. I have to have a denominator in order to have one of those.
I thought your denominator, since it was 1 and since there was an x above it, so it'd be 1 over 0. So
Was it-
I thought that's why you would have a slant.
Okay, understandable. The only issue with that is that your slant asymptote is actually going to end up being the equation itself. Like it's going to end up being x plus 2. And that's actually what we're going to need to graph here. So if anything, your slant asymptote is actually going to be the function that you're actually graphing to represent this rational function.
That was going to be my next question. I was going to ask if our slant could be the same as our function, because you know, like you can cross the horizontal asymptote. I didn't know if you could do the same, because that's what happened on the homework, and I was really confused.
Yeah, you can definitely do that. Or that can definitely happen. Do I have any x-intercepts? I have -2, 0. Okay. Remember, we can find that by setting our function equal to 0, setting our numerator equal to 0. We'll solve that. We get -2. What about a y-intercept?
0.
You plug in 0 for x to get your y-intercept. So we have all of our pieces of information. So when we go to graph this, yes, it is going to end up being, it's going to look like a linear equation. Doesn't mean that it is a linear equation, it's still a rational one. I have an x-intercept at -2, 0. I have a y-intercept at 0, 2. And I have a whole at 2, 4. So to connect all those, my best. This one is going to look like a linear function. Definitely not my best. Make sure you go around the whole. Did I go around the whole for the last one? Yes, I did. If you go around the hole, don't draw through it. I think in the video I accidentally drew through it. It's a mistake. Don't do that. Draw around it. And yes.
Miss Anderson?
Yes.
So this is still considered a rational function because it has discontinuity, right?
It still has discontinuity, and originally the function was a horizontal. Originally the function was a rational function.
Is this question that was on the homework going to count against us? Because I don't think a lot of us knew what to do because it wasn't an example in the video.
True. I'm not going to count this homework, to be honest. I'm not going to count any of your homework from last week. So. Other questions? Let's look at that one from your homework that has two vertical asymptotes. Someone read it off to me.
-5 over x squared minus 2x minus 3.
Okay, this is going to be another one that doesn't cross over the horizontal asymptote. But let's talk about this one. Okay, this does simplify down to be -5 over x minus 3, x plus 1. Yes?
Yes.
Do I have any holes?
No.
I have no holes. So that means that both of these pieces in the denominator are going to be my vertical asymptote. They're going to be located at x equals
3.
and x equals
-1.
-1. Do I have a horizontal asymptote?
Yes.
Y equals 0. Anytime your denominator is bigger than your numerator, it's always going to be y equals 0. Y equals 0. Do I have any? So that means I won't have a slant asymptote. X-intercepts?
No.
None. When I set -5 equal to 0, that's not a true statement, so I won't have any of those. But do I have any y-intercepts? Five over 3? Yep, because you'll get -5 over -3, so it'll be positive. Yep. And that was everything, right? All the pieces we need to find? Okay. So now let's graph this. Vertical at -3. Vertical at, positive 3. Vertical at -1. I have a y-intercept at 0, 5/3. So that's located in between 0 or 1 and 2. I have a horizontal asymptote at y equals 0. And since I do not have any x-intercepts, this piece that's in the middle is going to look like another parabola. Because the only way that this would actually curve to maybe look like a cubic function or something like that is if I had an x-intercept somewhere in between -1 and +3, which will cause the graph to cross over it. But since I don't, it's not going to. Question?
Would it also curve like cubic if there was no horizontal asymptote?
Yes. Oh, like instead of slant?
Yeah, but then I think it probably would have to cross over slant asymptote too. So.
It would approach. So it would kind of look like mini tiny quadratics like in between each of them. We can do it. We can do one like it though. So this one would curve like a parabola. Also, if you're unsure, I did it, I think, in every example in the video. Normally I don't do it, but you can also graph additional points just in case you're unsure if it does actually it's supposed to cross over in the middle. Okay? Like if I wanted to, I could plug 1 into my original function, or the factor form really doesn't matter. If I plug 1 in, this will give me -5 over -4, which is a positive 5/4. So again, I have a point at 1, 5/4, which is still above. If I wanted to, I could plug in 2. These additional points will help you in determining Yep, there's another one, 5/3. These additional points will help you determine exactly kind of what is also happening in there. So as you can see, it went down and now it's gonna start to curve back up. So yes, this middle part is gonna look like a parabola. I'm also gonna need some additional points because I need to know what happens over here as well as over here. What's the point I can plug in that's on the left side of -1? -2. If I plug in -2, that'll give me -5 for -1. So that'll be -2, -1. That 1 point alone tells me that this curve is in the bottom left. And plug in more points and it will show that. Give me a value that's to the right of +3. 4. So at 4, I'm at -1 again. So that lets me know I'm in the bottom right as well. So the purple, the green, the red, put it all together. That is what the graph of your rational function should look like. And this one was from your rational functions homework, okay? 4-1. True or false? Does this function have a hole at 3, 0? Well, let's take a look. In order to find my holes, I need to make sure that I simplify or factor the top and the bottom to see if anything cancels out. How does the top factor? And somebody online, give me how the bottom factors.
X plus 3 times x minus 3.
Okay. Anything cancel out? The x minus 3s. Okay, so if the x minus 3s cancel out, that means we do have a hole. We take the canceled out factor, we set it equal to 0, and we see that x is equal to 3. But remember, to find the y coordinate, we have to plug that number into the what?
Or the simplified fractions.
I need to plug into the simplified version, which is this x over x plus 3. So when I plug it in, I'll get 3 over 3 plus 3, which is 6. So in actuality, my hole lies at 3, 1/2. So true or false? Does the hole lie at 3, 0? False.
False.
Mm-hmm.
I picked false, but it said it was wrong.
Okay, I can go back and I can check that. I can definitely go back and check that. All right, let's do this one together, and I want to give you one to try on your own. This one here, you're dividing using long division. Dividing using long division. As you can see, this is an example of a rational function, and then on top of that, the numerator is greater than the denominator. So if you were to find your oblique asymptote, you would have to do division here, because again, the numerator is greater than the denominator. So long division, your divisor, which is your denominator, goes on the outside of that division bar. And then your numerator, which is known as your dividend, goes underneath it. But I have to be careful of what? Any missing terms. The same thing how it was with synthetic division is the same thing here. Okay, I'm missing which term? The x to the second. So you need to make sure that you put a placeholder in for any missing terms, just like you would if it was synthetic division. Then you ask yourself, what times 3x gives you 9x to the third? 3x squared. Okay? It's always the first term of your divisor going into that first bit of your dividend. Okay? Then you multiply that 3x squared by your entire divisor. What do you get? Was what x squared? 6x squared. Then you'll have to do what? You subtract. You subtract the entire function, which is essentially you're changing the signs of each of the functions. When you subtract, this turns into a negative. So does this one. And then your 9x to the third cancels out with the other 9x to the third. And I'm left with a negative 6x squared, bringing down the next term. And we repeat the process. What times 3x gives me a negative 6x squared? Negative 2x. And just so you know, I line my stuff up. You don't have to necessarily do this. I just, x squared is my x squared, x my x's makes things a little nicer, a little neater. Then I multiply. This gives me a negative 6x squared minus 4x. But I have to remember to what? Change the sign, subtract this whole thing, which makes this a positive, makes this one a positive. The main thing with any division, like old school number division, you want to make sure your terms are canceling out. So always remember to change the sign. This is a positive 3x, bring down the negative 3. One last time. 3x times what gives me 3x? 1. So then you multiply. That'll give me a 3x plus 2, but I have to remember to change the sign. This becomes a negative, this becomes a negative. Do I have a remainder? It's going to be negative 5. So division-wise, my quotient is 3x squared minus 2x plus 1. I have a remainder of negative 5, so that's going to be minus 5 over my divisor. If this was just regular long division, what would your answer be? That would be it in the black. But let's say you were asked to find your oblique asymptote. Well, your oblique asymptote would be just the quotient. So it would be 3x squared minus 2x plus 1. Would I have you graph that? Probably not, because I don't doubt I remember how to graph quadratics, but at least you're able to find it. Give this one a try. Using long division. Divide. 4x to the 4th minus 14x to the 3rd minus 14x to the 2nd plus 110x minus 84. Divide that by 2x squared plus x minus 12.
Oh, almost.
I wasn't missing any terms, was I?
Looks good.
Okay. Check in. What times 2x squared gives me 4x to the 4th?
2x squared.
I multiply. Yes?
Yes.
Okay. Change your sign. This turns to a minus, this one to a minus, this one to a plus. Goal is to continue to cancel out factors. That's what you want to do. Not factors, I'm sorry. Cancel out terms. Yes? Okay. What times 2x squared is going to give me a negative 16x to the 3rd? Yes? Don't forget I have to what? Change the signs. Let's go away. Yes? Okay. This is a little algebra that throws me off sometimes. What times 2x squared will give me an 18x squared? Positive 9. This is right here, I think is where, when I saw, at least for you guys online, It was that constant of your quotient that that was off from everybody. Like everybody got the first two terms fine. It was that constant though. Yes? Okay. Change your signs one last time. Did I have a remainder?
Yes.
Sure did. My remainder was an expression of 5x plus 24. So if this was asking for my oblique asymptote is just the quotient. So it would just be that 2x squared minus 8x plus 9. That's what it would be. If you were asked to divide the whole thing, your final answer would be 5x plus 24 all over your divisor. Questions? So with this one, we're just looking for that slant asymptote because again, the numerator is greater than the denominator, so I could use synthetic division here because this is a pretty simple one. I put a positive 1 in that backwards L, 3, -1, and 2 because I wasn't missing any terms. Always bring down your first term, multiply, add, multiply. Do I care about the remainder? No, I do not. So the question or the answer for the slant asymptote was there. Very good. All right, so for this one, we have to graph x squared minus 1 all over x minus 1. As we can see from the answer choices, this is one of those that simplifies down to be a linear factor, which it does. This is difference of perfect squares in the numerator. And as you can see, we have a common factor of x minus 1. So that means that we have a whole. The whole is located at +1 or -1. It's going to be located at +1 because remember you set the canceled out factor equal to 0, so you'll get x is equal to 1. That right there would eliminate this one here for C as well as for D because the x coordinate of the whole is actually 0, not 1. And so then we would want to plug that into the simplified form, which was over here, x plus 1. So 1 plus 1 ends up becoming 2. So we have a whole at 1, 2. So your answer should have been B. And on top of that, since this was the simplified form, it is a line with a positive slope, so you knew it had to be one of the ones that was going up. That's why it was B. Questions on this one? So for this one, you got to determine the asymptotes. Now, granted, multiple choice, you know, it's like cross elimination, right? If you get one part, you look and be like, oh, well, it has to be that one. All right? But how do we find a horizontal asymptote? You compare the degrees of the numerator and denominator. What's the degree of the top? 1. What's the degree of the bottom? Also 1. So since they're equal, we have to look at the leading coefficients. I have a 2, and then I have a, so it's going to be 2. But you got to be careful. Horizontal asymptotes, is it x equals 2 or is it y equals 2? Horizontal asymptotes are always y equals 2. Clearly, that one was your answer. Okay, it was clearly A. All right, but I find vertical asymptotes by doing what? Setting the denominator equal to 0. Majority of you guys picked B. If I expand that, and then divide it, I should be able to get my slant asymptote. That'll be an x squared minus 4x. Change your signs. Be 3x minus 6. This will be a +3. Multiply. I'm only doing it this way just to kind of harp on, you know, long division. So yes, it was y equals x plus 3. Very good. Last one we'll do is this one. Graph the function. No, the picture doesn't have any of them, but were there any holes? Out of curiosity. Yes, there were. If I factor down the bottom, you see that I have a hole at +3, okay? This graph doesn't show any of these holes, but it definitely makes it a little bit easier, the simplified form, to help me find that that slant asymptote, as well as where my vertical asymptote is going to lie, okay? So I'm using taking this opportunity to make sure that we have everything, that we know everything. The x coordinate of my hole is going to be located at 3. What about my y coordinate? It's going to be the y coordinate of my hole. For the y coordinate?
Would it be like 21/4?
At 21/4, but 35/4. Okay, 35/4. That is roughly 8 and some change. So 3/8. Okay, they should definitely have a hole in these. Tisk. I'm gonna have to write this company. But there should definitely be a hole at 3 and then 35/4. Where's my vertical asymptote located?
X equals -1.
X equals -1. So as we can see, that will eliminate B. That would also eliminate D. Okay. And then both of these have the same slant asymptote. But if I was to FOIL this out, that would be x squared plus 6x plus 8 divided by x plus 1. So I can do synthetic division with it real quick to find out that my slant asymptote is going to be y equals x plus 5. That's why it has a y-intercept at 5 and the slope of 1. What are my x-intercepts?
-2, 0, -4, 0.
Okay, so as we can see from the ones that remain, I'm looking for -2, 0, and -4, 0. No mistake. They're very small. I can't even tell the difference. What's my y-intercept? The first one's 0. What's my y-intercept?
0, 8.
8. That's just wrong. All of these is wrong. The closest one would be C. The closest one would be C. But all these is wrong. Good thing we did it all out so we can see it.
Like 5 something.
Yeah, these are just wrong. But we found out all the information ourselves. So really and truly, it should have been 0, 8. 1, 2, 3, 4, 5, 6, 7. Should have been here. My x-intercept should have been here and here. And so it should have curved a little bit more like this instead. But still, approaching the slant asymptote, approaching the vertical asymptote, not crossing or touching. Just to keep pushing the idea home a little bit more. What's the end behavior? Functions like this. It would be infinity. Well, for this first one, is it positive infinity for the first one?
Yes.
Yes, because look, as x is getting larger, it's getting further and further out to positive infinity. What about when x is approaching negative infinity? That's how we do end behavior for our slant asymptotes. It was a little crazy. A lot of stuff is going on this board, but I'm hoping that you guys were able to follow along. All right? But these are all your different features. How to graph fractional functions. Long division involved. Synthetic. Are there any questions?